section 4.3, graphs of polynomial function. So in this section we're going to talk how to plot graph of a polynomial function, and then we're going to talk about some of the definition, uh, and then finally how to find out all those information which help us to plot the graph. First of all, any polynomial function can be written in this form. This form. This is a generalization of polynomial function. It looks complicated, but this is not actually. So I'm going to show you, you know, uh, the information about. I'm going to tell you what does this mean. Like an minus one, an minus two, dot 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 means keep continue. It depends on what is the value of n, and this an minus one, an minus two, a1, a0. These are just a real number. It could be positive real number, negative real number, or sometime maybe zero. And n should be the n, whatever n we're using, it should be positive integer to be a polynomial. Or finally, for the last one, a0, I can also write it down as a x to the power 0, which is basically 1, so we don't write that thing. Okay, so these numbers an minus 1, an minus 2, dot dot dot, a1, a0, uh, up to a1, it's called coefficients of the polynomial function. So for example, the coefficient of x is a1, the coefficient of x to the power n is an. It's called coefficient. Okay, and then this a0, it has a special name. That's it's called a0 is called constant coefficient. Here is the mistake. Here the number an is called leading coefficient, and then number a0 is called constant coefficient. So this a0 is constant coefficient. I'm going to give you one example. Let's say f of x equal 3 times x squared plus 5 times x plus 6. Then 3 and 5 are called coefficients. 3 is the leading coefficient, because 3 is the coefficient of highest power of x, and then 6 is called constant coefficient because it's there is no x appear here. Okay, keep in mind, to be a polynomial function, the power, the exponent of x has to be this has to be integers, positive integers. Okay, only in positive integers. It means it could be 1, 2, 3, anything, the positive integers. And then for the final one, it's a x to the power 0, which we don't write, we just write 1 for that. Okay, so let's see some examples. For the first function, a first polynomial function, as you can see here, these are the polynomial function and this is not. I'm going to show you why. Just look at the look at the exponent of this x. If it's other than positive integer, then that's not polynomial. But here x to the power 4, so that is 4 is a positive integer, 2 is positive integer, and there is a constant term. Constant term is allowed. Okay, so that means this function is a polynomial function because either there is a x to the power positive integer or constant term. For the second function g of x, again you can divide each of these coefficient by 17. So you can rewrite this as a 4 over 17 x to the power 3, 2 over 17 x squared, 5 over 17 x, finally 1 over 17. So as you can see that the power of x, they are just positive integer or just constant term. That's why it's a polynomial. But for this one, h of x, if you divide each of this term by x, it will give you 4 times x squared minus 2 times x plus 5, and finally there is a 1 over x. So you can see here x squared, so this is positive integer, this is positive integer, there is a constant term, but because of this x on the denominator, there is no way you can write it as a x to the power positive integer. This is basically 1 over x. X means if you just bring that x on the numerator, it can be written as x to the power negative 1, which is negative integer. That's the reason this is not a polynomial. Okay, so now this is one example. Now you need to find out which one is polynomial and which is not, and then if it's polynomial, then you need to find out some of the information. For example, the function f of x here, is this a polynomial? So the only thing you have to look is the power of x. The power of x is 3 and then 2 and then constant term. So that means either there is an x with a positive integer or constant term. That's why it's a polynomial. So the first one is polynomial. So this is polynomial, yes. And then second one, degree comes from, if that is the polynomial, then degree comes from the highest power of x. In this case, it's a 3. Leading coefficient means the coefficient of highest power of x, which is square root of 3, and constant coefficient means it's the constant term in that polynomial. So these are the information. Yes, 3, square root of 3, and negative 1 over 6. But this is not the polynomial because of this x. This x, 7 over x, can be written as 7 times x to the power negative 1 because of the negative exponent. This is not a polynomial. Now, to plot the graph of a polynomial function, you have to keep in mind, there are 3 different graphs we have for x to the power 1, x to the power 2, and x to the power 3. X to the power 1 means it's just a straight line. X to the power 2 is a parabola, and x to the power 3, it's a cubic function. So after this point, whatever we're going to talk, that depends on if you have a polynomial of degree greater than 3, then the graph of the polynomial would be either like this or like this. That depends on the power of x, of the leading term. Okay. So if the leading term has even power greater than 3, then the graph should be look like this. Okay. And then if the leading term has odd power, uh, greater than 3, then the graph should be look like this. But that depends on what is the leading coefficient. If the leading coefficient is negative, then you have to flip it. Make sense? So one example here, the graph of x to the power 4 is this, which is very similar to the graph of x squared. Graph of x5 is look like this, which is very similar to the graph of x cube. So whenever you are dealing with a polynomial of degree greater than 3, always think about leading term. If leading term has power, even power, then it has to be similar to the x square. And then if the leading term has odd power, it has to be similar to the x cube. But keep in mind, it's not only x square or x cube. Sometimes you have the reflection. For example, negative x to the power 6. So the graph of this would be similar to the x to the power 6, which is similar to the x square. This is the graph of x square. But here, because of the negative x to the power 6, the graph of negative x to the power 6 would be similar to the graph of negative x square. Negative x square. Okay. So here, if you try to plot the graph, this would be very similar to the graph of x square. And here, this is the basic function here we're using without this constant. If you just think about, imagine the function without this 2 and 1, the function would be x to the power 5. So the graph of x to the power 5 would be similar to the graph of x cube, which is cubic function. Okay, and there is a leading coefficient positive, so it should be similar to the x cube. So these are the graph of negative x to the power 6 and x plus 1 to the power 5 plus 2. Look at here, they are very similar, but the thing is we are using the transformation. Transformation is shifting left 1 unit and then shifting 2 unit up. So the final graph would be this red one. Make sense? And for finding the exact point, you can always use the points from x to the power 5 by finding some of the points by making the table. You can always make the table, like for example, let's say x equal to negative 1, y would be 2, and then you can find the point. If x is 0, then y would be if x is 0, then y would be 3. If x is, you can keep continue. If x is 1, then y would be 1 plus 1 to the power 5, which is 32 plus 2 is 34. So you can find out some of the points to sketch the exact graph. Okay, there is a one information that's called in behavior. In behavior of the graph depends on the leading term. So this is the polynomial you have, and you always go to the leading term. Whatever leading term you have, the in behavior of your polynomial would be similar to that leading term. For example, let's say you have a polynomial function 3x to the power 5, 2x4, 6x minus 7. If you want to find out the in behavior, that means you are trying to find out what happens when I plot the graph of this function. What happens to the end, like to to the extreme right side and to the extreme left side. And that in behavior comes from the in behavior of the leading term, which is 3 times x to the power 5. We know 3 times x to the power 5 has a graph similar to the x cube. So as you can see that the leading behavior or the in behavior of this x cube is it's up to the right and down to the left. So the in behavior of this polynomial would be up to the right and down to the left. Okay, so if you had negative sign here, it would be just opposite. Okay, so I'm going to give you summary of in behavior of polynomial function. So here this is the graph of x to the power 5, negative 2x to the power 4, negative 6x cubed plus 8x squared plus 5x minus 6, and this is the graph, and this is the graph of x5. As you can see that the in behavior of this polynomial and its leading term, which is x to the power 5, this should be same. That's the reason to the right both of them should be up, and to the left both of them should be down. To the right means we're talking about what happens if you keep going to the right, and what happens if you keep going to the left. That's called in behavior. Okay, determine the in behavior of polynomial function. So this is the summary of our discussion. Look at the polynomial and look at the leading term. Here the leading term is an times x to the power n, and follow two-step process. Depending on the value of an, if an is positive, okay, then the right hand right hand side always go up, and if an is negative, right hand go down. That depends on your coefficient. So think about that. X square, this is the graph of x square, and this is the graph of x cube. Okay, for both of them, if an is positive, the right hand side is going to the in behavior for the right hand side going to the up. That is what it means. If an is positive, the coefficient is positive, then to the right it goes up. But if you look at the graph of negative x square, then you can see that right hand side is going down. That same thing happens for negative x cube. This is graph for negative x cube. For both negative thing, the right hand side is going down. So if an is positive, the in behavior for the right hand side would be positive. If n is negative, the in behavior for the right hand side would be negative. And depending on your n odd or even, we have two different cases. Look at here. If the degree n is odd, the graph has opposite left hand and right hand side. We know that very by looking the graph of x cube, because it's odd, so this would be opposite. If it's even, for example the graph of x square, this would be on the same side. So after finding the information about the coefficient, you will be able to tell either it goes up or down to the one side. And then by looking the value of n, if it's odd, this should be opposite. If it's even, this would be same direction. If n is even, this would be of the same direction. And that depends on if an is a positive or an is negative. Okay, one example. You have given two graphs and we need to find out what is the degree and what is the leading coefficient. We have to guess. So for the first graph, as you can see that the right hand side is going down and left hand side is going up, so it's opposite direction. So the degree should be, for sure it's odd, because for the even degree this would be on the same direction. Here, because they are on the same direction, that means the degree should be even. For the leading coefficient, because that for odd degree, the right hand side is going down and the left hand side is going up, which is just opposite of, think about the graph of x cube and think about the graph of negative x cube. So it's very similar to the graph of negative x cube. So the leading coefficient should be negative. And here for the even, think about the graph of x square, or think about the graph of negative x square, and match the graph. As you can see that both sides are going up, so that means the degree is even, and the leading coefficient should be positive. because that happens only for the positive even power of x. So the odd, this is for odd and negative leading coefficient. This is for the even and positive leading coefficient. Okay, and while plotting the graph of polynomial function, it's always helpful for if you find the y-intercept and x-intercept. They give you the points where a graph will passes through x-axis and y-axis. So you can find out the y-intercept by putting x equal to 0 in the polynomial function, and you can find the x-intercept by equating the function 0 and solving for x. For example, let's say here this is the polynomial function. How do you find the x-intercept? You just have to equate this function 0 and solve for x. So this is x cubed minus x squared minus 4x plus 4 equals 0. And solving means you can solve by using factoring method. And here for the y-intercept, you just need to find out f of 0. Okay. If I do that for the x-intercept, this is the factoring method. So I factoring by grouping method. So I make the group of 2. I factor out x squared from the first 2, and then that will give me x minus 1. I factor the 4 from the last 2, and that gives me x minus 1. So x minus 1 and x minus 1 are common factors. So I factor out x minus 1, and the leftover would be x squared from here and negative 4 from here. I can further factor out this x squared minus 4, and that gives me x minus 2 and x plus 2. So if I solve this equation, it will give me 3 different options: x equal to 1, x equal to 2, and x equal to negative 1. And for the y-intercept, I just have to put x equal to 0 in the given function, and that would give me the y-intercept. So if you have to plot the graph of this function, then for sure you know that this graph is passing through positive 1, positive 2, and negative 2. So this graph is passing through these 3 points, and f0 equal 4 means maybe from here, which is 0, 4. We know that the graph is passing through these points, and we also know the in behavior is similar to the x cube, which is up to the right and down to the left. So the graph should passes through these these points, and it should be look like this. Approximately we have a lot of information about the graph of this particular function. We need some more points to join these points. We need some more points so that we'll see one approximate graph of this function. And you can find out the points from here, 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 here. You can find out a couple of points to exactly see the graph. So this is a polynomial function, the same polynomial function we're talking about. And then we know the in behavior, we know the x-intercept, y-intercept. So we have tentative idea how to plot the graph. Now the zeros, as you can see that these zeros are very helpful for plotting the graph. So the zero means if x minus c is a factor of a polynomial function, then by solving that x minus c, by equating that x minus c to 0, we can find out the real zero of that polynomial function. If f is a polynomial function and x equal to c is a 0, then x minus c is a factor. So these are the some finding. If a factor x minus c occurs n times in a polynomial, n is an integer greater than 0, the 0 x equal to c is said to have a multiplicity n. So what does it mean is, let's say you have a polynomial function f of x, and these are the factors: x minus 2, 3, x minus 1, let's say 2. Then x equal to 2 and x equal to 1 are two zeros of this polynomial function, and this 3 is called multiplicity of 2, and this 2 is called multiplicity of 1. Based on that information, multiplicity, it would be easier for us to plot the graph. So here in this case, it's for the first polynomial function, x equal to 1 is a 0 with the multiplicity 2, and for the second polynomial function, x equal to 1 is the 0 of the multiplicity 3. So now the observation, or the idea about this multiplicity is, whenever you have even multiplicity, the graph touches that 0. Touches means like, for example, here x minus 1 whole square is a polynomial, x equal to 1 is a 0, and since 2 is an even multiplicity, graph comes here, touches that point, and goes back to the same direction. Touching means it will come from some left hand side to that point and go to the same direction. But for odd multiplicity, as you can see that graph should crosses that point, meaning it goes from down to up or up to down. So graph will touch the x-axis at a real zero with even multiplicity. That is our finding. Graph will cross the x-axis at real zero with odd multiplicity. So shape of the graph of a polynomial function near a zero of a multiplicity k depends on the value of k. If k is even, if k is greater than 1 and it's even, then it should touch that point either this way or this way. You just have two options. Okay, and if k is odd, then it should cross the point either this way or that way. Look at here, it's coming down and then crossing the point, it's going up and crossing the point. You just have two different options. Now in this example we're going to find out all real zero, their multiplicity, and we need to decide whether graph touches or crosses at that point. So here, this is the polynomial x times x squared minus 1 times x minus 1. If you factor out more, and this is the factorate form, this is the factorate form. By looking this factor, you can see that x equal to 0 is a real zero with the multiplicity 1. Multiplicity comes from the power. X equal to negative 1 is the multiplicity 1, and x equal to positive 1 is the multiplicity 2. So while you plot the graph of this function, you have to make sure that at 0, negative 1 and positive 1, so look at here, at negative 1 the multiplicity 1, so that means it should cross, the graph should crosses that point. So the crossing happens in two ways. Either it comes from up to down or from down to up. So we just have two different options for the negative 1. Either the graph would be look like this, or the graph would be look like this. Okay, so we just have two options. So for 0, same thing happens. For 2, either for 1, because the multiplicity is 2, either the graph would look like this or the graph would look like this at that point exactly. Okay, and that information comes from the multiplicity. So this is our finding. The graph must cross the x-axis at x equal to 0 and x equal to negative 1 because of their multiplicity, and must touch the x-axis at x equal to 1. So tentatively, as you can see that this is the graph of that particular function, this polynomial function. I use some graphing tool to show you how it's crossing. So here you can see that at negative 1 it's crossing, at 0 it's crossing, but at 1 it's touching. Okay, and you can have this complete graph. This is what we're going to discuss next, but for now just focus on crossing and touching. Okay, so let's look at the the function we were talking before. This function, polynomial function, x cubed minus x squared minus 4x plus 4, and these are the factors. So we know that all these factor has a multiplicity 1. So all this 0 means x equal to 2, x equal to negative 1, x equal to positive 1, and x equal to negative 2. So we know we have negative 2, positive 1, and positive 2. These are the three zeros. This is the example we were talking before, and this is the y-intercept. Now because of their multiplicity, we know that the graph should cross this point, and the graph is already down to the left, so it should cross like this. At 1 it should cross like this because the graph has already the function has already positive value here, and then at some point it should go back and cross this point to join this graph. Okay, you should have a way to join all these points, and because of this crossing and touching here, it's just a crossing all the time. So you can see that it should cross from bottom to top, top to bottom, and bottom to top. I'm talking about bottom, it means below the x-axis. Up means above the x-axis. So this is the tentative graph. Okay, so this is the tentative graph. But how do you find this tentative thing? You can find more testing value. For example, at negative 1 it's positive, at positive 1.5 it's negative, and you just join them by using the smooth hand. Just join them by using the smooth hand. Okay, so the one thing you have to be careful here, or focus on one thing, that is turning points. Turning point means we see from the graph that there are two turning points. Look at here, the graph is going up, and at some point it starts going down, and then it goes down down down, and at some point it uh, you know goes up. So these are the called turning points. Depending on the degree of the polynomial, the turning point you must the maximum turning point you will have is at most n minus 1. N means the degree of the polynomial. So we see from the graph that there are two turning points. A polynomial function of degree n has at most n minus 1 turning points. That is the one thing you have to always keep in mind. So for example, let's say you have a polynomial function x cubed x squared plus x plus 1, and for example, let's say you want to plot the graph of this function. You cannot plot graph like this, because as you can see that there are 1 2 3 4 4 turning points. That's not going to happen, because the maximum turning point for this polynomial would have 2, which is 1 less than the degree of the polynomial. So you have to be careful. This is not the right graph. The maximum turning points would be 2. So that is one helpful tool to while choosing the graph of a polynomial function, or while plotting the graph of polynomial function. Okay, some of the steps I'm going to give you here which might be helpful to plot the graph of polynomial function. And step 1, first of all, determine the in behavior, meaning based on your degree of the polynomial and its coefficient, you can always find out what happens to the extreme right or extreme left to that polynomial function. And then after that, find the y-intercept and plot it, and find the factors of polynomial function and find the real zeros and their multiplicity, and then find the testing value. But remember, keep in mind, to plot the graph exactly, this class, college algebra, the things we cover here, that is not enough. Remember that without calculus, which is another class, which is you need more information, more knowledge to plot the exact graph. So without calculus, there is no way. Calculus is one subject, if you might know already. Without using calculus, there is no way to determine the precise coordinate of the turning points. Okay, here we just try to see how many turning points are possible, and then we try to find out all this information to find out one approximate graph. Let's see, this is the problem, and we are going to follow this 4-step process to plot the graph of this polynomial. First of all, this polynomial is already in factorate form, so it's easy for you. And the degree of the polynomial comes from if you add the exponent of the factors. So here the exponent is 2, here the exponent is 1, so the degree is 3. So this is 3-degree polynomial. And because the coefficient, this -2 here, that would be the coefficient of the highest degree. So negative is the coefficient of the highest degree. So we have 3-degree polynomial, and then the coefficient of highest degree is negative. So the in behavior of this polynomial would be look like the in behavior of f of x equal negative x cubed. And we already know that the in behavior of negative x cubed is up to the left and down to the right. So the in behavior look like this. And now you can find out the y-intercept by putting x equal to 0 here. So these are the information we found. Because the degrees are with the leading coefficient negative, so the left hand up, right hand down. So that's the in behavior. That's the graph of the in behavior of this polynomial function. And for finding the y-intercept, just put x equal to 0 here and solve, and that will give you the y-intercept, which is 8. Now we need to completely factor the polynomial if it's not already factored, but this polynomial is already factored, so finding the real zeros are easy. Just equate each of these factors, to 0 and solve for x. So x equal -2, x equal to +1. So these are the zeros of this polynomial function, which is also called x-intercept. And look at the exponent of these factors. This is 2. So the multiplicity of this 0 is 2. That is the multiplicity. And this is 1, power 1. So the multiplicity of this 0 is 1. Meaning the graph is going to touch at this point and the graph is going to cross at this point. And now we also need some testing value to find out exactly. We need some testing value as well that will help us to plot the graph. So now x equal to -2 has a multiplicity 2, x equal to 1 has a multiplicity 1, and I choose this testing point. Let's say x equal to -1, x equal to 0.5. These are the value I'm going to get for y. Just put x equal to -1 here. You can choose any testing point. Okay, and now what happens is if I use all this information, I already know that this function is r. The in behavior has to be left to the up to the left and down to the right, and these are the x-intercepts, and then this is the y-intercept. And I also know that at -2 the graph has even multiplicity. Even multiplicity means because it's coming from up, that has to be like this, and at +1 it should be, because it's already positive here, it has to go from top to bottom. So I already know that this is how graph is going to be behavior at this 0. By using all this information, if I just try to plot them using my free hand, this is a tentative graph of that polynomial function. So that's why I have this tentative graph here. To plot this tentative graph, I also use this testing value. Okay, now sometimes they give you the graph and they ask you some information about the graph. So by looking this graph, the first question you have to answer is the degree of the polynomial function even or odd? So look at the in behavior to answer that question. Because in behavior is in the opposite direction, it has to be odd. And then, is the leading coefficient positive or negative? So think about this. Odd, this is the odd for x cube, and this is the odd degree for negative x cube. And just compare your graph with one of them. So as you can see that the graph of negative x cube is the in behavior of graph of negative x cube is similar to the in behavior of this graph. So this means the leading coefficient should be negative. So odd because the graph starts up and finishes down, and negative because the right hand behavior finishes down, or very similar to the negative x cube. Now, what is the value of the constant coefficient? What is the value of the constant coefficient? All this you can find out the value of the constant coefficient by looking the y-intercept, because when x is 0, whatever value it gives you, that is the coefficient of that's a constant coefficient. Constant coefficient means, if you go back to that definition of polynomial, there is a0. This is called constant coefficient. So when you put x equal to 0, everything else would be 0, only a0 would be left over. That is your y-intercept, or that is also called constant coefficient. Identify the real zeros and state of each. So as you can see that the real zeros are -5, -2, +1, and +4. So -5, -2, and then +1 and +4. So by looking these zeros here, you can see that -5, it's crossing, the graph is crossing at -5. So the multiplicity of -5, which is x minus -5, which is x plus 5, would be one of the factor. The multiplicity, the power should be odd, because it's crossing, the graph is crossing. Whenever graph is crossing, the multiplicity has to be odd. X plus 2 is another, because of this negative it becomes +2. X plus 2 would be another factor of this polynomial with the odd multiplicity. X minus 1 is another factor. No, sorry, it's touching here, it's not crossing, so it has to be even. Okay, it has to be even, the multiplicity has to be even. And at 4, which is x minus 4, the multiplicity has to be odd. So whenever you try to form a function for this graph, so you can see that that function has x plus 5 as a factor, x plus 2 as a factor, x minus 1 as a factor, x minus 4 as a factor. By looking these zeros, and the exponent of the factor would be odd, odd, even, and odd by looking this crossing and touching behavior. So now these are the things I was talking here. So we have all this information, and now sometimes they ask you to choose which one is the right function for this particular graph. Then you just look at, just compare which factor has all those properties. So we need odd for the -5, odd for the -2, 1 even for the 1, and then odd for the 4. So everything else has odd multiplicity except 1. So look at that, one of these equation, one of these function, odd, odd, even, and odd. So this might be one possible answer, but you have odd, odd, even, and odd. So the third one might be another possible answer. Second one, no, because there is even multiplicity, so it is cancelled out. This one also odd, odd, even, and odd. This might be another option. So there are three different options with this multiplicity. But how do you find out which one is the right option? So now the next thing you can see is the coefficient of leading term, negative, positive, negative. And we already know that the coefficient of leading term should be negative. We already answered that question, right? We already answered that question by looking the in behavior, which is similar to the negative x cubed. So it has to be negative. So this is not the right one because it has positive coefficient for the leading term. So now you just have two different options left over. Now what you can do is you can just find out the y-intercept, which is 2. Just put x equal to 0 and see which one gives you the 2 value. For example, if I put x equal to 0 here, 0, 0, 0, that will be 5 times 2 times -4, which is 40, divided by 10 is 4. So this is not the right one. If I put x equal to 0, 0, 0, 0 here, it will give me 40 over 20, which is basically 2. That will give you -40 times negative is positive 40 divided by 20 is 2. That's why this is the right answer. So you cannot write down exact function, but if you have given choices like this, you can find out which one is the right option for that particular graph by using multiplicity, zeros and their multiplicity, and then in behavior, and then y-intercept. So this is the right option.